Hi. So the purpose of this video is to talk about customization of MATLAB plots. If you are unfamiliar with MATLAB plotting, I recommend go watching my other video where I explain some of the basics of how you get a plot, as this video will focus on more of the aesthetics behind the MATLAB figure. So in this example here, I just made an x vector from 0 to 4 in increments of 0.01. I have a y vector that is all those x values squared, and then I plotted them in a figure. And here's my figure. Now, there's a lot of things that we can edit about a graph. You can edit things on the outside of the plot. So your axes labels, the size or fonts of those labels, the ticks, which are basically what the increment of these numbers are, what you want to visualize, the title above the graph, what you're trying to show. And then inside the graph, you can do things like change what this plot looks like. You can change the line style. Do you want it dash? Do you want it thick? Do you want markers, which are basically symbols that go where your points are? Do you want a different color? Things along those lines. Do you want a legend on your graph or a grid? That is what this video is going to cover, those types of concepts. So let's go ahead and first start with our axes. And the commands that we use to edit our axes or to add a label to it is simply X label. Maybe I'll come over here and say that this is time. And I'll explain this notation. What I do usually when I show something in a report or some type of paper is I will write what I'm plotting in words. I will then include the variable that I'm using to describe it, especially if there's equations in the paper. And then I'll include the units. So if I were to run this, you'll see that on the bottom below the x-axis, that will appear. There it is. Similarly, the y label is the same. Maybe I'll do pressure, P, and pascals, for example. And if I run this, you see that that pops up right over there. Pretty easy. Those are some pretty easy functions. Now, we'll talk about properties more in detail later. I guess I can do it now. If I ever want to edit something about a plot in MATLAB, what I need to do is include inside of my parentheses, and this doesn't just apply to X label, this applies to basically everything, including the plot command itself, is that if I were to include some sort of property here, followed by the value of that property, that will allow me to change those things in the code. And the reason why you might want to do this in the code is because it is nice to have the ability to run a whole script without having to edit your graphs later. We'll talk about a way to do this if you have a graph and you just need to make once for presentation or something, you don't care about saving it. There is a quick way of doing it if you don't know how to code it. But for me personally, I always try to add the customizations of my graphs inside of my code. And you'll have a preference ultimately of what you want your graphs to look like. You'll get used to a color you want to choose or a line width or something like that. And it's nice to have that in the code. So with this concept in mind, I'm doing X label followed by the label, and then I can include properties. Now, the property that I might want to mess with, for example, is the font size. Look how tiny these labels are. So what I'll do is I'll put my property in single quotes because it's text. And the font size will be a number, just like you would see in a Word document or something along those lines. Maybe I'll do 20. And I won't do the Y label so we can compare. If I run this now, you see that this got bigger because of the fact that I have changed the property of font size to 20. So again, we have our normal syntax where you have plot of something or X label of something. And then right after that, you include properties that you want to change about it. So let's say we do font size here. I'll do 20 as well. And now we have these bigger labels. Maybe there's a reason you'd want to change the limits of the X and Y axes. So you see what I mean by limits is the minimum number for the X axis is 0, and the maximum number is 4. Well, what I can do is use the command xlim, and then inside of xlim, I will include a matrix that tells me the start of my x-axis and the end of my x-axis. So let's say I go from 1 to 3. So what that means is that instead of 0 being on the left side of this whole white figure, we're going to zoom in to 1 and 3. So if we do that, we see that we're zoomed in to 1 on the x-axis and 3 on the y-axis. And our y-axis changed accordingly, actually, where we see that we went from 1 to 9 because that is the max and min y values set by these points. Now, of course, I can override that if I want. Maybe I say I want to go back to 0 and to 16, which was the original y-axis limits. If I plot that, now we see 0 to 16 on the y-axis and the x-axis from 1 to 3. I can go even crazier. I can go past the plot. That plot started at 0. Let's say I do it from -5 to 10 or something random. I'll make it 5. That's past 4. And I'll make this from -10 to, or -30 to +30. So this is saying my x-lim will be from -5 on the left to +5 on the right, and my y-lim will go from -30 to +30. And if I do that, we see that here's my quadratic that I plotted from 0 to 4, and now I've just increased the space of my figure. So xlim and ylim are very useful for that type of thing. Another thing I might want to change about my axes is what numbers are showing here. So maybe I'll do a command called xticks, where each of these little dashed lines are considered ticks. And I can include in there which ticks I want to show. So if I were to make a matrix, let's say that is -5, -3, 1, and 4, if I run this, we'll see that those are the only numbers that show up. -4, -3, 1, and 4. Or maybe you want to, if we go back to what we had before, which was -5, 1 to 5, if we do that, it comes back. Maybe you want to do smaller increments or something more fine. So maybe I'll start at -5, go in increments of 0.25 and go all the way to 5. And we'll see that we'll end up with a graph that MATLAB will format automatically to show you all those things that they can't fit. So obviously this is a little bit extreme, but you can change that with xticks. And similarly, you can do the same thing with yticks. Or instead of going to -30 to 30, maybe we'll go -30 in increments of 5 to 30 instead of 10. So right now it's going in increments of 10 on the y-axis. If I go in increments of 5, I've added in some more ticks there. Pretty nifty. Another thing that you can do, I'm going to clear this figure and we're going to plot it again to get rid of all the grossness that we just did. Set those back in. I'm not going to mess with the limits because this graph looks good. And I won't mess with the ticks either because they are pretty good by default. A lot of times you want to change them depending if you have multiple graphs on the same thing, or if you're to use subplots, which I recommend checking out in another video if you're interested. You might want your axes to match for multiple plots. And so you set up the xlim and the ylim and the xticks and the yticks so that you make sure that everything matches well. That might be a reason you want to do that. Another thing you might want to do is change the literal labels of these numbers. So instead of it showing 0, 0.5, and 1, you can do something like xtick labels. Now, we will talk more about this in the future, the idea of curly brackets, but just accept this for now, that if I were to use curly brackets to describe some numbers, you know what I'll do? I'll also make the xticks less. So maybe I'll do 0 to 4, so we have less of them. So it'll be 0, 1, 2, 3, 4. So 5 things. Maybe I write 0. I don't know why you'd want to do this. But, you know, it's good to have these capabilities in mind. if I have my labels changed, the numbers that MATLAB is using to plot those points are still hidden, but they're still used. They're still plotting these things. So if I were to do this, you can see that all of my labels have changed now to the words. And I can change those words to anything. I can switch them around and make it really confusing if I want to 0, 3. I guess it is 3. Oh, no, it's not. 7 and 10. It doesn't change the fact that the plot is still storing these numbers. If I do that, I can do that to mess with somebody if I wanted to, which obviously you wouldn't want to do in a professional setting. But in general, you can add whatever you want there. Maybe you're plotting, I don't know, hours or minutes. Maybe you have something that's like 0 to 60, and then instead of doing 61, you'll just go from 60 minutes to 1 hour. And then you're just showing that time at some quantity as a function of time, where you're labeling them in a more convenient way than just numbers. But that is a possibility. The same thing with y-tick labels. Y-ticks, same deal. I can do 0 in increments of 0.5 to 16. And then I can do y-tick labels, which I'm not going to do. But that would allow us to add labels to each of these points if we chose. The last thing I want to mention is, at least for the outside of the graph, well, 2 more things we have to do. The first thing I want to do is, if you notice, these axes are pretty tiny. The font of the numbers is small. So what I like to do, and if you look at any code I've ever written, I will always do this in this order. I'll plot it, then I'll do X label, Y label, and then the following command, which says set, where what I will do is I will grab some property from the table. And the way that MATLAB stores this is GCA. This stands for get coordinate axes. And then I'll include my property and the font size I want to do. Maybe I'll make it 20. We'll see how obnoxious it look with the ticks that I just did. Let's change the ticks back. Let's go from 0 increments of, I don't know, 4 to 16 or something. So I just go ahead and run this. Okay, that's a little bit better. Now what I'll do is, if I do this, I should also probably do the same thing with the X ticks. Oh, it's not even letting me. Oh, the labels. Ugh. Okay, I'm just going to clear the figure and do this again. Sorry. Let's do this again. We plot this. I do my x-axis. Everything else is fine. That's cool. So now what I want to do is set my graph coordinate axes, my GCA, to a higher font. If I click that, you'll see that all these numbers have gotten bigger, and this is a lot easier to read. It's more aesthetically pleasing to the eye that you can visualize and see what these numbers are. And of course, you can mess with the fonts. It doesn't have to be 20. It could be something else. But that is really useful for us to be able to adjust the size of those types of things. The last thing on the outside is the title, which is really simple. This is my pressure graph, let's say. I don't know. If I want to edit the font size, I include the property and then the number. I'll do 20 to stick with the rest. And then it'll show up right at the top. So now that we've covered what's on the outside of the graph, we want to focus on how we can edit things on the inside. So what I'm going to do is I'm going to copy and paste this plot here, and we'll go ahead and we will plot this in our figure. My pressure graph apparently went also with this. That's okay. I don't care about that. If you want to get rid of a title, for example, I can do something clever like this. I can get rid of it. You can also redo the figure without it. Maybe what I'll do is I'll run these specific sections to give me my axes labels back. You know what I'll do? I'll show you exactly what I do when I'm typing code myself, is that I will do X label time, T seconds, Y label pressure, P pascals. I'll set my graph coordinate axes to a bigger size. Let's say I usually do 14. And I usually make that my figure. So here's my figure after adding in those things that I always include. The next question is, how do we change the inside of the graph? Now, the inside of the graph, the first thing we want to change possibly are the properties of the curve itself. So some of those properties might be the color of the graph. So what I can do is I can include that property color followed by the color I want to change it to. And if you were to type help followed by plot in MATLAB, you can see under here that they have a whole table devoted to different colors, different markers, solid or dashed lines. This is what we call the line style. So if we were to include the word color, we can then use the full name of the color that MATLAB has stored, which is only these 8. And if I do that, you'll see that I've changed the color to red. I can also do the shorthand notation. If you look, these are the shorthand notations of those corresponding colors. So black is K. If I were to do that, we will see that this is a black line or a black curve because of that. So that's how we change colors. But if you notice, MATLAB only has 8 colors at its disposal. It's not super helpful with its color palette. We only have 8 colors. So how do we use multiple colors? Well, MATLAB uses an RGB type of notation, which stands for red, green, blue. Colors are made up of combinations of red, green, and blue, depending on the intensities of those colors or how much presence those individual colors have. And what you would do is you would create a matrix of red, green, and blue values where values go from 0 to 1. Where a value of 1 means 100% of that color that you're specifying, and 0 means 0%. So if I come to color and I write this matrix out, let's say I do 1, 0, 0. 1, 0, 0 says, give me all of red. Well, I say no green and no blue, so if I run this, I get a red graph. Now, to help you remember this, you can do Roy G. Biv. You have an R and you have a G and a B in not alphabetical order, but it's in order of the rainbow, Roy G. Biv, to help you remember RGB. If I were to do 0, 0, 1, that would be blue. There's our blue. And if you wanted some random color, you could just do random amounts. Let's say do 0.2, 0.6, and 0.4. Now, we have no idea what this color would actually be, but we can probably take a guess. That's going to be something that's more on the bluish and the green side because there's not a lot of red. So if we run this, we see that we have kind of like a teal. And as I increase a specific number or decrease the others, you'll see that will end up being more and more like, in this example, green because it's RGB, and that's more of a green color. If you do 0, 0, 0, that implies that there's no color, which means that the color that we would plot is black. And if we do 1, 1, 1, which is all the colors, that would give us white. And you can't even see it. You can kind of see down here that this graph is overlapping with the axes. You can kind of see it's white there, but obviously it's hard to actually see. I can't even highlight over it. But that is what is happening when you change the color. So let's go back and change this to R just to make it red. Another thing that you might want to change is the line width, because sometimes if you have a lot of graphs or a lot of lines on a certain graph, it's hard to differentiate between them if they're all really thin. So if you use the command line width and then say a number like 2, which is a number that I commonly choose, I'm not sure what this number means exactly. It could be some arbitrary scale by MATLAB. It could be something to do with the pixels or an actual unit. I'm not sure. But if you run this, you'll see that my line will get thicker. And depending on the number that I choose, you'll see that it gets thicker and thicker. Let's do 100. Let's just see how ridiculous that looks. And now we see that we have a much thicker line that goes from 0 to 4 at this quadratic because of how big I made the line width. So I'll do 2, or you could even do decimals like 2.5 to make it a little bit more apparent and make it more powerful, I guess, in your statement, if you want to think about it like that. Another thing you can do is change the line style, which depending if you have multiple graphs or not, it's good to differentiate between different things. So maybe I'll do line style, and I can choose one of these 4 options that MATLAB has to offer. Solid is what is the default value. If we're to do dotted, and we run this, we'll see that our line is now dotted. Maybe I'll make this a little bit thinner so we can see it better. Let's say I were to do a double dash, that'll be a dash line. Dash dot will give us this dash dot behavior. If you look and zoom in, you see that it's a dot followed by a dash, and so on. And the last thing you might want to do is include markers. So if we think about markers, we can set a shape of what we want here. So maybe I'll pick a letter here, maybe like D for diamond. I do marker followed by D. And you can see it's really thick, but if you zoom in, you have a lot of diamonds. And the reason it's so thick is because our X values are so fine. So let's say I make this 0.1. We'll see that we'll end up with less diamonds because they're plotting a diamond at every single point that exists. So that's a diamond. You can do an S for square. You see I'm changing them. You zoom in, you see it's a square now. I do an asterisk for star. It's actually kind of hard to see with the way that I set this up. But you can pick any sort of shape that you'd like. Pentagram. Okay, so you kind of have this giant star, which is pretty cool. Hexagram, and so on. Now, another thing that you can do, we'll go back to circles. If you want to edit those markers themselves, is that there are commands like marker face color, where you can say you want to change the face of the marker. So if I want to say I want my marker face color to be blue, if you look, you'll see that all of these got colored in on the inside with blue because that's the face. Another property might be the marker edge color, which right now is red. Maybe I'll change that to green just to differentiate. If you look at the edge of the circle, right now it's currently red with a blue face. If I do that, now I have green as my edge and blue as my marker face. And because we set the graph over here to red, that's why the lines are red that are connecting the markers. The last thing we can do also is marker size, which we can choose some arbitrary number. I think something like 14 might be good. We'll see. That's pretty big, but depending on what you're trying to do, that might be fine. If you want to go smaller, we can see that we have these markers now with these specific properties. So these types of things are really useful when you're trying to illustrate something in your graph. I think that that's everything involving the graph itself. Let's talk about some other things that are useful. Let's, I'm going to clear the figure. And what I'll do, we'll set up a new section. I'll plot this for the color of blue. I'll do a marker of circles and a line style that is dashed, because why not? I'm going to hold on and I'm going to plot a second y. Maybe I'll make it the square root of x. Plot x, y. I'll call this y2 just to differentiate it. X will be the same. And I'll make this color red. And I can do these in any order I want. I'll make this dash dot and I'll do a marker that is a diamond. When I plot this, we see that we have these two graphs now. Where if you look at the first one, which is y equals equal to x squared, we have the dash lines. We have a marker with a circle. We haven't specified the face color. It defaults to white. And we haven't specified the color of the marker, but it'll end up matching the color of the line if you want it to be. And then for the square root of x, we see here's our square root of x graph, which has a color of red, a line style that's a dash dot, which is hard to see with the markers in the way, and the markers are diamonds. Now, if I want to differentiate these, we have to use the legend command, where the legend command will plot or make our legend in the order that we plotted our graphs. So in this situation, I plotted x and y first. So this would be maybe my quadratic. And my second entry would be a square root. So if I run that, we see that those are the graphs that we've plotted. Quadratic and square root. And if you do set GCA font size to get everything back up to speed, let's do that to fix our graphs. We see our legend gets a little bit bigger as well. And this will plot in the order. So I switch the order here. You notice that this first term in the legend is the blue dashed line. Well, that will match with our first thing that we plotted. That's how you do legends. I think the last thing I want to talk about, oh, there's two things I want to talk about. The first thing I want to talk about with the graph is really easy. Is I want to turn on a grid. It might be hard to tell, but I have added these grid lines here that might make it easier to read a graph. So that's my graph. Now, the last thing I want to mention is that let's say I open up, I'm going to pull up this figure here. And as I alluded to earlier, sometimes you want to plot something once and you don't want to deal with the code. Maybe you don't like it. Maybe you don't remember it and don't want to spend the time Googling what it is. Something really useful is the property inspector, which is up here in your figure window. Notice that I undocked it. I could click that. I can come over here and say undock figure 1. I can click this property inspector, which is in the top. If I click that, what'll pop up is the ability to change these things using a user interface, a GUI of some sort. So I can click anything I want here. Like let's say I click the legend. And you can see that I have things I can change. I can change this to y is equal to x squared if I want. I could change this to y is equal to the square root of x. And if I do that, I see my legend change in real time. If I want to click the line, I can change the color of the line. I can do anything I want. I can change the markers. Pull this down. We can see marker edge color, marker face color, the things that I've talked about before. You can edit all those here, which is really cool to be able to do that. And this property inspector is great for that because I can come in and I can change like my axes labels. Here's my X ticks. If you look at my X ticks, it tells you all the ticks. So here's my ticks from, well, maybe that's why I was confused. I did X ticks before. Yeah. I edited out something from the video that I made a mistake on. But in general, you can come here and change your tick values if you wanted to. So let's say I want to change Y ticks. Maybe I do 0, 5, 12, 15, 20. I don't know, random like that. I might come here and do this. So I do 0, 5. Let's say I make this a 12. Specify tick values in ascending order. Yeah, that should be fine. Oh, that's another mistake I need to edit out of the video. But in general, this property inspector is very useful for us. So I hope that this video made sense. If you have any questions, please let me know. And as always, good luck coding, and I will talk to you soon. Okay, bye.